Good evening. A warm welcome to all of you to Coffee at DBG. This is Arunima. And Coffee at DBG is actually an innovative experiment that provides a platform for the technocrats to share their knowledge and to keep at par with the trending developments in technology. And the journey of Coffee at DBG has come a long way. It is really a successful one. The success of this session or this innovative experiment is being owed to many people. Actually, the efforts, the support, and the hard work that is put in by many people. So on behalf of DBG, I take this opportunity to thank, to recognize, and to acknowledge the efforts and the hard work put in by the n number of people behind the success of the session. The synotia of today's of this 35th edition of Coffee at DBG is a session led by Mr. Vijay Dev on Beyond React, Flux and Redux. This is actually a continuation of the 34th edition of Coffee at DBG. And to start off with today's session, we have Mr. Rahul with Techbites. So basically, he provides us an insight of the latest developments in the field of information technology. I invite Mr. Rahul to handle his session.
Hi everyone. So I am here with Techbites. Techbites is nothing but trending news happened on last month. So I have picked 5 topics on last month news. So we will start with the biggest one. Finally, Linux is on Windows. So you could directly run Linux command from Windows. We know till now we have run these scripts or commands using third-party applications, but from this release we don't need any virtual machine or any third-party tools, which means it's purely native. So the next one, WebAssembly may go live in browsers this year. So from this year onwards, you could write your web application using C or C++ and directly run on your browser using WebAssembly. And you could use your JavaScript native APIs as well as HTML5 APIs and WebKits. So next one, Git 2.8 has been released. The first feature on 2.8 is they have introduced parallel fetch module, submodule. So in that features, you could download your parent repo as well as modules in parallel manner. And the second feature on that is they have removed rsync support from 2.8. Okay. So next one, a tool for managing secrets. So we all are working in IT field and we know the importance of API keys. Okay. So Vault is a tool used for encryption. Okay, so in this, for an instance, I will to access the S3 bucket, you need a key, right? For each and every request, you will use the same key to access S3. But using Vault, for each and every request, you could generate a unique API key using S3 API. So your credentials will be secure. Also, you could use Vault to store your credentials such as passwords, APIs in your server itself. So they provide you CLI, HTTP API interface. The last one, Rancher OS. So we all are familiar with Docker services, right? So Rancher OS is an operating system purely based on Linux or Linux OS and is sized around 20 MB only. So in this, your Docker will be running purely on top of Linux kernels, and All your essential services like DHCP will be run as a container, and you could have multiple Dockers as containers, so which will be very fast in this Rancher OS. And complete the thank you. Now I invite Vijay Dev to start his Beyond React section.
Thank you. Hello, 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 hello. Uh, oops. So good evening. My name is Vijay. Today I will be taking uh, beyond React Redux. Actually, we'll be covering something with Flux and Redux. This is purely highly technical talk, a continuation of the previous one. So you're free to leave whenever you want. Uh, again, the Redux and Flux actually came into existence because a new frontier itself has opened up, and there is so much to be done, so much to be understood. Originally, when I choose this topic, I had an idea that I can contain everything under 1 hour, 1.5 hours. But as I started working on it, it just grew big, big, and big. And you can see that the last 3 items have been striked off because, again, those things themselves are a big topic to be discussed upon. But besides that, what I will try to do is to give you a fair idea of what React is, what Flux and Redux is, and how they make front-end app development much, much easier. So, do I want? Okay, one more bit of information. All the code that you are going to see here is JavaScript, but ES6, ES7 syntax. I will try to fill any blanks that you may not understand. So if you have any doubt regarding ES6, ES7, you can shoot. And finally, there is a lot of slides to cover, so let's try to get that within the available time. So you learned React, or if you don't know React, React is a framework that will help you render everything in your browser faster. Simply put, let's go back to a couple of years back where everything was a website. Nowadays, there are fewer and fewer websites. There are more and more web apps. So everything that you see on the web app actually, well, most of it is actually rendered by JavaScript or the HTML5 technologies rather than the server, right? So once you compute everything, you need to render it on the browser so that the user can interact with it, use it, so on. So there are many frameworks to do that, but they all fail at one critical area, which is the DOM rendering, and React excels at it. So I think that will be a good basics for you. So you learn that. So that if you are familiar with MVC, React is only a part of a V, not the entire V, just a part of a V. So you learn that. So where can you use it to build React apps? Yeah, you can build React apps that can just be for some experiment or inside a website. Basically, if you have attended or you already do React, you can know that anything that can be represented as a component can be built using React. So by component in React, yeah, in React, when I say component, it's just a piece of code, something like a class. You give him some input and he will render something out. That's it. For example, if you give him a set of images, he will create you a slider or an accordion, so on, provided that you actually created the component to actually build that slider or accordion, and all the behavior code goes inside the component. So it's a wrapped function or a class, you could say. Uh, Again, simple component that can receive data and render output. So obviously, any of you who have worked in the front end or who is a backend developer and occasionally does some small JavaScript or jQuery stuff, and it works for the time being, but if the client asks you to make it more complex, things either fail or the rendering becomes much slower. It takes a lot of time, the browser is hanging and so on. So React can actually do that. You can just use React to build that and it will just work. At this point there is no requirement of that React is being used inside an application, but no, you're not using that. You're just replacing jQuery with React. Yeah, let's move on. I will cover more. So again, focusing on the point again, component has its own contained behavior too, or you can say life cycle component. Okay, so I have to explain you these two things: functional component and life cycle component. So function components is just like pure functions. You just give them some arguments, they'll process it and give you back an output. That's it. So let's think it in HTML way. You give him some inputs, give him some data, he will render out the HTML. So for example, if I give him an array of links or array of object that represents your menu, a data blob that represents your site's menu, and you give that to this functional component, you will just render ULLI, ULLI, ULLI-A, ULLI-A, and so on. So that's just a functional component. It doesn't do much beyond that. Lifecycle component is basically, yeah, it's a functional component, but it also gives you the opportunity to do things like component will mount, which means you're about to load into your DOM. If you want to do something, you can do it now. Component did mount, component will unmount, component, yeah, will unmount, and so on. You can have internal state. For example, if you're creating a custom select Dropbox, so, and I created a component for custom select combo box, and it will render it very beautifully. So the data that I need to give in is a set of values that will be shown, and additionally, if any of them is already selected, right? So that is the only data that you're giving to the component. The component takes that data and just renders that beautiful select. All the behavior that I just mentioned, when you click it, it will open up, you can scroll, you can choose multiple, and so on. Those are all the behavior that you have in it. And but there is one more information that is required for that combo box to work. Is the combo box open or closed? The person who actually initiated the component doesn't need to tell him that, okay, please be open or please be closed when you click it, or something else happens, so on. So that information is also part of a life cycle component as compared to a functional component. Let's move on. So basically, it can replace any framework's rendering part of you. Okay, so we'll see how that works. So definitely, you can create hybrid apps with React. If you are already working with any application, a lot of code has been written and deployed. It's running, and there are few bottleneck areas, few UIs that have serious rendering bottleneck, or you're going to attempt to actually build something new that is highly complex, and you're pretty damn sure that if you try to build it using jQuery or some relevant framework, it could fail. So you can actually have your own application as it is written now and just replace the rendering part with React. Okay, and Okay, so let's try to understand Flux. But before you try to understand Flux, you have to understand what is an unpredictable state. So at this point, you have to understand the state, the word state, the overlap between, but it means that the moment you actually load Gmail, it loads up and it has all your filter, chats, everything. That is the initial state of your Gmail. Everything that could change, you could say something happened, an action happened. You clicked on one of the chat, you clicked on one of the mail, you clicked on the search and so on. That I did, but there can be also network activities that coming along. New mail has been received, new chat has been received, and so on. So if you have built an application where you're pretty sure that you can't tell what will happen in the next state or the next state or the next state, it's going to be a big problem, because I'm not sure if you have felt that way before. If you have built a medium to large scale application, if you have not, again, if you have not introduced to the Flux architecture, you kind of get a feeling that, yeah, one simple example with Angular.js would be two-way binding. So what if I let's say scope.watch and I'm updating that model in that watch itself? What will happen? Yeah, infinite digest loop. Why? Because it's not because Angular understood that you are trying to update a model updates a view update, and the view updates a model, and that model updates another view, and so on. Angular doesn't understand, because he is actually in flat with those shapes. The only way he understands that is like, okay, you have evaluated same thing almost 9 or 10 times, and then just he stops everything and just gives you the error. He doesn't understand that you are trying to do many-to-many connection at the same time. So what I'm trying to say here is that if you are creating an application in such a way, it has an unpredictable state. You can't say what is going to be the next state. You can't say that if I change this value here, I can't say for 100% sure what all things will change. Have you been in such situation? Yes, because you are sharing, for example, you are sharing one bit of data with a lot of people, or a bit of code with a lot of people, or a variable is, hello, or a data model is being shared by reference. If it is being shared by reference, which means that anyone can change that, which means that anyone who is, basically all the players inside your application are referenced same object. So any one of the player change that object, it's going to reflect, it's going to get reflected in every other places, right? So that's what I meant by unpredictable. So let's take an example of what to a few years before we actually started regarding Flux internally. Okay, it's very simple to read. You would see a notification on the message icon. You click on it, and it will just go away. And then after a few minutes, it will come back again. You click it, there is still no messages. And it would just keep going back and forth. Have you had this issue? Yes? No? Never seen this issue? Okay. So the reason why it was happening is because the code they wrote is unpredictable. It can't say that what will happen next. If a network activity came, the notification counter, if the user clicked on it, if the logic that determines has the user seen it, basically, obviously that is how they determine should I show a notification counter or not. So the way they built it was something like this. So you have a model that represents your data and the view that renders the data. So you can see now the connections that going are back and forth. There is many to many connection. So this is an unpredictable state. This is how pretty much everyone creates an Angular application or a backbone application, right? So if you change something in the model, that model is going to update this view and this view and that view. And if that view is updated, this model is updated. If that model is updated, again, this model is updated. Again, this model is updated means the cycle is now complete. It goes on and on. So you can't predict what's going to happen if I change something, if I click something. Predictable state. Every time, no matter what happens, you always know what's happening. So to do that, you have to define what's going to happen. You have to define an action. If user is doing something, I need an action that represents what the user just did. If it is a network thing, I need an action that should represent exactly what just happened, right? So an action that represents what just happened, user clicked, or a new message came, or a poll had an we polled for data in the server, and he returned me a valid data that I need to render. That goes through a dispatcher. We'll come to dispatcher later on. That dispatcher sends that action to the store. Based on the action the store will get, he will try to update himself. And once that store is updated, or the model or the state inside the model the store is updated, the view will get rendered. Now, there's one interesting thing that you have to see for yourself is that are pointing only one direction, and the only can sending out an action. When something you can't just say dot on. You will be asking, okay, why can't you just have that submit button, submit, click, take the whatever the user has typed to do array, and then once the to do array is updated, just list to do that. No, you can't do that. You will have to create an action first, and that goes through the dispatch. Make sure that the you does that. Dispatcher. if you get an action. In Flux, what dispatcher does is that whenever an action comes, he will dispatch that action or will call the callbacks of not only just one store but all the stores. And the store will decide, do I need to respond to this action? Do I need to process this action? If I have to process this action, I will try to understand what this action is, what the action type is. And based on that, he will update it himself. Right. For example, let's think about Facebook, the notification counter. So the store will have just a value, notification underscore count. So an action came, new notification has been received. The action came through dispatcher and reached the store called notification count, and he will just plus plus notification count plus plus. That's it. The store got updated. The view will get notified that I have updated, and so on. I know this is a very simple one, but we are going to explore more. Now, action is a defined entity that represents what happened. So it should not be allowed to be created by any of the players. I mean, any of the players in the entire application. It should only be created and issued by a particular part of the application called action creator. So it's in charge of creating actions, obviously. Action represent how you want to change, what you want to change. To change the state of the application, you have to view render, sorry, or the view render differently. Sorry, you have to fire an action. So basically, that was the previous example I said. Okay, user type something, and when he hit submit button, why can't I just take the data and just show it in the browser? No, you can't do that. You have to actually fire an action, and the action would say add to do, and this is a text that the user tried to add, right? Action creator creates the action with a type and a payload. So the type will define what kind of an action it is, and the payload will have the information, may or may not have the information. Doubts. I see a lot of blank faces. Okay, how many of you have actually done polling? Okay, how many of actually use get, put, or post? $.ajax. And what do you write inside the success? You are directly modifying the DOM, right? So that is unpredictable state. If you are modifying the DOM directly, or if you are directly modifying your model, you are not sure that how is it going to affect everyone else. So the same scenario, let's go back to the same scenario. You wrote $.ajax and it has a success, and you got the data inside the success, and you know what this just happened, you know what just happened. So rather than changing yourself, you're going to fire an action. The action will have a type that defines what kind of action it is, and the data will or the payload will have the data that you just fetched. And then the application will determine that dispatcher and store will determine how it should be processed. Does that make any sense? No. Got the simple idea. Why are we doing like that? Because to avoid many-to-many relationship and just have a unidirectional flow. Ultimate goal is to have a predictable state. Okay. Action is passed off to the dispatcher. So there is a lot of code in the. So this is a structure of action, right? So there is a type that defines what kind of an action it is, and the payload. Right. So it can be hello world, but since the code is there. So here. See, let's say this is todos.js. So basically, this is a place where user actually typed something and he just pressed enter, right? So rather than updating the view himself, he's going to call an action creator with the data. That's it. He's not creating an action. He's calling an action creator called add to do with the text. And the action creator is going to dispatch an action, type add to do and text. This is ES6 syntax. Since this is supposed to be text colon text, and since they are both the same, you can just write text. You don't have to explicitly do that. And this guy and this guy and this guy is just a function. That's an arrow function. The advantage of using an arrow function over a normal function is that inside a normal function, the this or the lexical this will always point to window, but in arrow function, the this will automatically point to the proper guy. For example, if you have a function inside a function, so the inner functions this won't point to the outer functions this. It will always point to window. But if you're using arrow functions, the this will work great. Okay, so let's try to see the code here. So this is just a dispatcher that's just saying that add to do is a function. He will get a text. When he gets a text, just call dispatcher.dispatch, type and text, right? So that add to do is here, right? This is a reference to the previous session if you have attended that, and this will be the type of the action. Okay, so let's just move down. Okay, so dispatcher, it's basically a big registry of callbacks. So how many of you have seen Sherlock Holmes movie? Or the series, anything. So he constantly goes to the telegraph office to send some message, because at that time that was the fastest way to communicate with people. So when you give a message to the telegraph office, he actually formats that into a very specific way. Have you noticed? Have you ever? I've never sent telegram myself, but I've seen telegrams being sent in the movies. So you can see that it is in a very proper format, what the telegram is and what the content of the telegram is, right? So dispatcher, wait. So you could say that an action is just like that. You want to do something, but you don't know how to do it. So just go to your, I totally missed that example. You go to the action creator. So in real life example, you go to the telegraph office and you say to them, I want to send a message to this guy from this guy for this purpose. And the action creator will create that telegram in a very proper format, something like this, and it will be sent across. Now this is a standard structure that is understood by many players inside your application. Okay, now comes the dispatcher. So obviously this action is received by the dispatcher and he will be sending it off. So basically it's a big registry of callbacks, which okay, let's try to relate to an example that you may understand. AngularJS model. Everyone knows that. That in AngularJS model can be a string, can object, and so on, array, and so on, so on, so on. So let's try to make it a little bit more complex. It is a store that not only contains data, but contains the logic of how to change that data. For example, you have a store that has a data called to-dos, that is an array, right? And it has a logic how to add a to-do inside, how to add a to-do, how to toggle a to-do, how to delete a to-do, so on. That logic. And that is your store, right? Now the store needs to be like, so when a user adds a to-do, obviously an action will be fired, right? So basically when the action is fired, for that store to add that to-do inside to-do array, he has a method called add to-do, right? So what the store does is that he will take that method called add to-do, he will go to dispatcher and register it. Now you get the point? Okay. So the Facebook example, you have a store called notification counter, and he has internally, he has private data called count, and he has an exposed method called increment count, decrement count, right? Let's say like that. So he's going to go into the dispatcher and he says that if a particular action comes that says increment the count, please call this method, which is increment count function, and similarly decrement count. So the dispatcher has a registry that basically a directory that is registered by each store. So when an action comes to a dispatcher, he will send that action to every store who has registered with the dispatcher, right? So add to do, action type called add to do will be sent to a store called notification count. Sorry? Yeah, okay. Yeah, dispatcher will send it to. I'm so thirsty. Dispatcher will send, dispatcher will send that action to actually to both guys, the store that's going to do add to do store, and to do store, and also the notification counter store. So since the type of the action is add to do, the store called notification store will actually ignore it because he doesn't have, he don't need to process that. So I will get to that. I'm actually. Yeah, let's take a simple example. You guys all work here. Let's say like that. And there is a friend desk secretary in that office. So mailman comes and he will give her a letter, and at some appropriate time she may deliver to you, or she will keep it in the inbox area. When you are going out, you can take your mail and leave. That is a simple scenario. But today you just ordered something on Amazon and you want to get that before you leave, right? Okay, so you are a store. You run to your secretary and the front office staff and then say that if you get a mail from Amazon, type is equal to mail underscore from underscore Amazon, please call me. And the call me is actually a function, a callback function, right? And the secretary can actually, once she gets the action from Amazon, she can just call that function and you will get that data, that package, you will get that package. So that is the idea. But here is the interesting thing. She won't just come to your seat and give that to you. She will come here and she will shout that action. So which means every one of you can listen to it, but only one person will respond to it. That's the point that I was making. Stores can come to dispatcher and register what they want to do, what should happen for a particular set of action. No matter what the action is, when a dispatcher gets an action, he will send that action to every single store, and only those stores who have registered for that action type will process it. Now is it clear? Okay. No, there is only one dispatcher. Okay. No, you are missing. No parallel, not parallelly. So first of all, when you fire an action, it can be like you are firing just one action, but other people can also fire actions simultaneously. No. The action is received by dispatcher, and he will only process them synchronously. Yeah, at a given time, there is only one action that is being processed by the application. Any other action that is a little late will have to wait for that previous action to be completed. No, yeah, it is a single. No, the point here is that if there are two actions, increment and decrement, and if you try to process them together, you end up with an unpredictable state. You don't know what's going to be that count the user is going to see, right? But yeah, but one came first. The guy who came first gets the first preference. This application has to process that first action, and only after the processing has been done, the second action will be processed. The dispatcher will only allow the second action to go through once the first one is done. That's why we have React, right? He's super fast rendering the views. Yeah. 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 No. There are many applications running at the moment. Yeah. The two big of them you actually visit almost every day. I'm pretty sure you visit one at most almost every day, which is called Facebook.com, and the second one is Instagram.com. React and Flux actually is a collaboration between the teams between Facebook and Instagram just before they bought Instagram. Right? So there you have it, two big applications running on Flux architecture, Flux React architecture right now. And do you see it breaking? Yeah, the reason why it's yeah.
I would like to understand is in Java, right?
Yeah.
When it's a multi-threaded guy, right? And you can define that a particular resource can only be accessed one at a time.
Yeah.
Right? So there's no ambiguity of the state of that resource.
Yeah.
Did JavaScript in ES6 get that capability? That's my question. If no, then it's more of like a pull or pop kind of functionality that's being happening in dispatcher. It's just pulling.
Yeah, actually the registry itself is an array basically.
You answered the question. I got it.
Sorry for not understanding you properly. Okay. In Flux, basically, I'm just going to present Flux so that I can boost you to Redux. And I assure you that by the time you reach Redux, you will feel much more lighter, let's say. Okay, in Flux, what is a store? Store holds all the state in the applications. You can have multiple store. I'm not saying that you can have only one store. You can have multiple store, and each store holds a particular state of the UI. For example, notification counter holds the state for the notification count on your Facebook application. That can be changed when a notification comes. That can be incremented when a notification comes. That can be decremented if you actually viewed that notification on your mobile phone. Does that make sense? You have your Facebook open up in your Chrome and also in your phone, but when the notification came, it wasn't viewed inside your machine, but from your mobile phone. So on the application that is running on your browser, we'll get two actions: number one to increment, and number two to decrement. Okay. Yeah. You put the example of this yeah. Yeah. Create actions and dispatcher store. Yeah. Yeah. Basically, in Flux it's an event, but
is that the paradigm shift?
Yeah. You can't say like that. It's just what Flux and Redux do. You are free to come here and use that model, or you can choose anything else.
Normal style Ajax response.
Yeah.
DOM update or do model update. Now we don't do that. We pass events. And
Yeah.
event will take care of choosing which is the right dispatcher and updating the right. Then it will update the model.
Exactly. So you can have the same event-based architecture right now without using Flux. But the one thing that is missing from that is the dispatcher. Dispatcher is the guy who makes sure that at a given time only one event is being processed. Everything else should be queued, right? Even when you're actually using the browser, the scroll event, all the things that you try to interact with, it actually goes through a queue. All those events are not processed at the same time. If one of the event actually has frozen the browser, everything you do subsequently will be held back in a queue. It won't get processed. That's how the browser itself works. Okay, it's synchronous. Okay, so that's what Flux. Yeah, yeah. Yeah, continue. I can hear you. Yeah, not only the dispatcher, but you could say a set of protocol of how things should change, just to make sure that the application state is always predictable. You know what will happen. It's never going to be it's never going to be a scenario where you could guess that it could end up in an unpredictable state. That's the main idea of what you want to achieve. Yeah, yeah, yeah.
There is no unpredictability. You agree to that? When we go more Angular style, React style, where we say, okay, there is a model associated to a view, and when that digest cycle continues, then there is a concept of unpredictability coming up.
That came into because when you are using jQuery, pure jQuery, the model actually is a ghost. Yeah, what I'm trying to say here is that if you're doing pure jQuery, your model is either globally shared with everyone, or you don't have a model. I mean, model is like a ghost, pretty much like a ghost. You're using DOM to store some data, or locally somewhere. You don't have a genuine Angular style model anywhere, right? Or if you're working with Backbone, you don't have a model or collections, things like that. Once you reach that state, which means you have created your architecture in a way that you will have set of models, and the model will store the data. And when the model, the data inside this, data inside the model change, the view should change. And then you go to the next step. When this view changes, I should update another model, and that model may have connection to somewhere else. So at that point, you are in the unpredictable state.
My point is this unpredictability comes because we chose a framework.
No, it's even if you so basically what Flux actually solves is that the reason why Flux exists is that even though you write your code 100% proper, you do tons of regression on it in dev and the live and the product environment, you can still reach in an unpredictable state. Well, I will give you a small simple example that I gave in the last class, which is I need a print functionality. So when you click on the print functionality, he's going to fetch all the results first. He's going to fill all the results into DOM, and then print, window.print. So when will you know that DOM has finished rendering? There is no way to do that. So what I used with AngularJS was set timeout, and that was good. jQuery also, you have a problem. We have a problem. I'll tell you. Inside the success, you will say .append and immediately window.print, right? So the second, you're assuming that the second line will only be executed when all the DOM activity has been done, right? That is your assumption. And sometimes, even if that assumption is breaking at some point, you will try to wrap that window.print inside a set timeout, right? Now, why your assumption will break is when you have more than 2,000 set of data that you need to update in the DOM. That is a lot of data to be present, build up in the DOM, and the DOM will definitely take more than 0 seconds to actually render them, right? So there is no way for me to tell when it finished. So I did that. It worked fine in the dev server. It worked fine in the production server. It broke in the live. It broke in the live spectacularly. It was in one print. It was showing the loader still because the set timeout fired even before the network was still going on. Number two, the network completed, but it just printed blank pages because the DOM hasn't completed rendering it. Actually, it hasn't even started rendering it. So, and it was an unpredictable state because sometimes it will print blank, sometimes it will print 2 pages, sometimes it will print everything. And this changes from client to client because one client may have little data, other client may have very big set of data. So that is an unpredictable state that which I would like to avoid. So if I had created that with React, which I did later on, I have a method called component did update. That is a callback function available with React. So you can, inside component did update, you can say window.print because you are 100% sure that it has rendered. We have lots and lots of slides to cover, more than 100 slides to cover, and we have just barely scratched it. So I'm going to go a bit fast. Okay, so inside the store, you have the logic to change the state of the store. The store himself is like a dictator, and he can define how the state of the store will change based on an action, which is not good actually. One can't directly request data from the store. There are no, I mean, you can't set this data inside the store. There are no setters, only getters. One must submit an action that will go through dispatcher and ultimately reach store, and he will decide how he wants to take action on that particular, how he wants to process that action. Once the store is updated, he will emit an event which will be listened by the Vue or React to re-render your DOM. I'll explain that quickly. So this is the structure of a store. This is pretty complex, but that's how Flux does it. So you can see let's underscore to-dos. That's a private variable, pretty much a private variable. You have a to-do store, which is basically an object. And this is just a ES7 spread operator. So basically you could say to-do store is an object where jQuery extend. I use jQuery extend merge. So basically, even.prototype, the methods inside even.prototype, obviously prototype is an object, will be merged to to-do store, which is why a method inside that is available. Yep. And he also created his own methods. So spread operator, this guy, and along with that, please add these two things. And ultimately, what the object is to-do store. So he has a method called getAll, which means that if a view is listening to a store, he can call to-do store.getAll to get all to-dos. He can't directly access underscore to-do. It's private variable. And again, emit change is here. That is when, okay, forget that. Please don't look at that. So that's what to-do store is. Now, this code is going to register itself with the app dispatcher. So what is it going to dispatch? Again, this is a function, this is a callback. This is a callback that will be called when an action comes. That's why the function, callback function, will get the action, and you can just check what the type of the action is. If the type is add to do, push to do or text.print inside the to-dos, because as we saw previously, type is to do and payload has the text. So in that, and then once you, this at this point you have actually changed, modified the internal state of the store, right? Underscore to do has been changed. So you actually emit an event for emit to store.emit, which will be listened by a view and will update. Okay, so the view itself, yeah. This is a complex bit of code. I recommend highly that we skip past it because in Redux it's very, very simple. Yeah, I will explain to that. Basically, there are few lines in the top. Import action types from some file. That's again, if you have written any node code or if you have read any node code, something like require.
Your action, your dispatcher is there.
Yeah, your
How the cycle is completed on the
anything.
dispatcher.
Yeah,
That rule is mentioned.
yeah.
And how the cycle completes. Whereas one the action gets completed in the cycle change, it goes to
The view.
the view part.
Yeah.
So that's store part. Store there.
Yeah, in Flux store, he is the complete dictator. He can register himself to the dispatcher, and he can decide how to modify an action. I mean, based on an action, how should the state of the store modify, and he can decide when he wants to make the change. He can delay that, or he can even decide.
You are coming to action dispatcher store.
Yeah,
Where is the view coming?
that's next.
So you can see here.
Okay. So the view itself has two guys. Why two guys is if you go into much deeper React part, you can the components that you create can be categorized into two guys. One who is only taking some data and printing something. For example, ULLI, ULLI, ULLI. He will just need an array of data. What should be there in between those each LIs. And then there is a guy who will get the data. He can decide what he needs to do with the data, so on. So that's what's the difference between a functional component and a lifecycle component. The lifecycle component is like a container that can grab the functional component or a presentation component. He's just presenting everything. The lifecycle component doesn't have any HTML outputs. Okay, no HTML outputs. So if we are going to look into the view, he's just a dumb guy. He will are in charge of taking the state and render it for the user. And also he's the guy who will be accepting any user, like for example, on click, on key up, etc. The view is the presenter. He is unaware of everything that is happening behind the doors, action, dispatcher, store, state, nothing. He just gets the data and he just presents it. That's it. Only knows the data that's handed to it and how to format the data into output that people can understand. Basically, take the data, print the HTML. That's it. The controller view guy is on top of the view. This is the guy who is actually constantly communicating with the store. He talks to the store that, okay, I want to know when you get updated. Please give me the state. Please give me the data. Get all. To do store.getAll. So this is the guy who's going to call those methods, and he's going to pass down that to the view. Middleman between the store and the view. So does it when the state has been updated, collects new state and passes the updated state to the view. This let's just skip all this and just go here. So I think this is much more easier for you to understand rather than reading some text. Store, controller view is a presenter, action creator is the guy who is going to create. This is the telegraph office, going to create the standard way of how then action should be represented. This is a dispatcher. So as I mentioned that even before the application is available for user to interact, the store will say, hey dispatcher, here's a callback. Can you notify me when actions come in? So whenever this guy will get an action, he will try to call the callback that was registered by the store. Okay, so here you can see callback number 1, callback number 2, so on, so on, so on. All the callbacks registered by each and every store. And he doesn't know which action should be processed by which guy. So once he gets the action, he will be sending it out to not only this store, but any other stores. Okay. Yeah.
And if I forward your slide correctly, store and notify the
No, there is no notifying. He is just registering one time. At the initialization, he just registers. That happens as soon as.
So dispatcher will forward to the, when I saw this, the arrow should go towards the store. Here the arrow came towards the dispatcher.
What I'm trying to say here is that I will try to give you an example based on Angular. Service.getData.then. Have you written that code, right? You have written that code. Or let's say $http.get bracket URL.then. And inside that then you give two parameters, right? Both of them are functions. The first function will be called if the $http.get was a success. The second function will be called if it was a failure, right? Okay. So the $http.get has registered two functions to $http.get, and in a way that if that is successful, please call the first function. If it was failure, please call the second function. They both are callbacks for success and failure. Similarly, the store created such a function, app dispatcher.register. So rather than actually you taking the store's code and then going inside dispatcher and writing it up, dispatcher has exposed a method called register, and it can have multiple arguments, parameters, and he will just register those things. That's what's happening here, and that needs to happen only once. You don't have to re-register again and again, right? Only once registered. So once this actually happens synchronously. Sorry, you are initting. You are actually initializing at that time. So he registered, and at the same time also the controller view, because he needs to render, but to render he needs data. For rendering, for data, he has to go to the store and it says what's the latest state, and he has the state, and he will send that state to him. Done. But after that, he also says that okay, go ahead and render this. I'll let you know if the new state comes in, which is the controller telling the view that this is the data that I received from the store. Please try to render it, and if the state changes, I will call you again to re-render it again. That's cool. Now, that same process has one more step where the control view says to the store that, oh yeah, please notify me. Since I have subscribed to your store at the time being, I should be notified when you change. Fair enough? Okay. This is the setup side. Now comes the interesting part. This is a user action. Not an action, but I typed something and I pressed enter. So this is the guy who actually presented the view, presented the UI to which the user interacted, and he said hello world. So he doesn't know what to do with that. He has just a text called hello view, and he sent that to action creator, add to do inside text. So this guy know what to do with it. Type add to do text hello world. So this here is the action that represents exactly what has happened right now, and send this action off to stores when they are ready. When they are ready, which means a store at a time could be in between processing a particular action, and you should not send another action to the same store, right? And that is moderated by the dispatcher. If there is an action that is in the pipeline, no other action can go in unless and until that particular action has been processed by each and every store who registered with all of them. Yeah, you got the point. Okay. Now comes the interesting part. Dispatcher sends that action to the store. Okay, an update state action. Let's see how I can update the state for this. So as I mentioned that the dispatch will try to send the action. It will send the action to every store. So even if that is not a relevant action for him, the store will try to see what that action is. If it is relevant, we will process it. If it is not, if it isn't, we'll just ignore it. Okay, so he actually created a new state. There has been a state change, and since there was a relationship between the store and the view, he will tell the control view that yeah, I have a new state. So he's like, cool, send it me over. So that was a request, and he sends the. Oops, I actually used the wrong one. This is state that is being passed over to the control view, and you know the rest of it. They just handed me some updated state, type in. Okay, so this guy is unaware of anything. All he knows is he'll get some data and he has to render them. And whenever something happens on the UI, he needs to call up the action page. Now, does this solves? I mean, now you get a small picture of how Flux works. Now, the interesting thing about this architecture is that every time it's fully predictable what's going to happen next. And yeah. Okay. And the guy who has the full authority power to decide should I implement that change request is stored. Because he's the guy who's getting the action, he's the guy holding the data, he's the guy who will be modifying the data into the next state, and he's the guy who will be giving the data to controller view. No one can change the data of the store without an action. Okay. Flux to React Redux. So basically, Redux is an implementation.
We can arrange that was great.
Yeah, sure. Thanks a lot.
Sure.
Question?
When an action comes in,
Hello.
So now this one I will definitely go through. Why? What's the problem with Flux? Flux store contains two things: state change logic and the state itself. Which means that if you want to change the logic of how that state should change, you are basically changing the store itself. If you are changing the store itself, the data is going to be flushed. Basically, you are reloading it, right? So there is no way to test it out. You can't test it. You can't do hot loading. Hot loading is a very good concept, which is very popular with React. Again, it's not good to have the data and the logic that defines how the data should be modified in those places. This is the second point that you mentioned. Yeah, okay. Redux store only keeps the current state. Redux store are single state trees. So Redux store only contains the data. There is no code or logic within the store that defines how it should be modified. Redux reducer has a state change logic, and it works something like you give it the current state and the action, and you get the next state. You're not modifying the existing state. The existing state stays there, and you just replace that with the new state, which means you can just track the previous state. And if you keep tracking those commits, we can actually go back. You can do undos.
In React, that can solve. In Flux, that you can't do that because in Flux store, that underscore to do was modified directly. You didn't create a new underscore to do and replace the old one. Okay. Exactly. State getting stored, and each action changes state in the same state. No tracking. You don't know once the action is being processed. You don't know what was the previous state. We can do reduce promotion, by which it means that you could have two different stores representing two different set of data, but the logic to change the data is pretty much similar. So which means you end up with code repetition. The code, the logic to actually modify a particular state is now duplicated between two different states. But if you actually move it out inside a reducer, you can actually do a reducer composition. Multiple states can use the same reducer to modify themselves. But I'm not going to go into it. Those who know that it's awesome, and those who don't, please try to understand. Basically, hot loading is when you change something, you don't have to reload the browser. You don't have to reload the browser. It has been changed. Everything is modified. The new logic is in place, and the data that was accumulated until this point is not flushed. You can't do that with Flux. Okay. This is a lot of things. Some of the days, some of the time. That is the guy who created Redux, and you can go to this link to find out a long list of things that he defines how you can change it. I'll share the. Okay, so basically how he started doing it was simplifying a Flux store because he wasn't happy with it. Every time an action comes through, the state gets changed, and he can't track that. The state is always modified by action. So he tried to restructure the store of Flux. Okay. This is pretty much the same code that we saw previously. I have removed the ES6 syntax. Now it's pretty much something like $extend assign, right? Take this object, merge it with this object. Sorry, take this object and merge it here. That's the concept of extend. So, for example, if event.editor.prototype had a method called getAll, that would be replaced by this one. So, and we export that. And here is your dispatching. Registering to the dispatch. And dispatching of this stuff. This is just a function. And the function will, this is the callback function, right? And that callback function will be called by the dispatcher. And when he calls this function, he will provide action to it. And here you can check what's the type of the action is. You have a private variable called do, push the text to it, and then let it change. Yes. So, first question was, why should I register? And it's not good to actually update the same internal data itself, internal state itself. So he just changed that to exporting that as a handle function. So basically the point is that you create a function and you give that to dispatcher and dispatcher you call that function. So why not just create that function and export it? Someone will call handle. That's an appropriate time. The second one is that this again is spread operator what to say it's not an object, it's an array. Take this array and add this text to it, and whatever is the result, put it into the to-do. You didn't modify the original to-do. You didn't modify the original array. you're creating a new array and you reassign it. So which means that the previous array is still there. If you want, you can track that. You didn't change. There is no the original array that was. Yeah, basically you're not changing the original array. So basically, I can write a code right here, right between these two guys, where commit underscore to do. Again, what I'm saying is that just after print, I'm going to do commit current state, and inside that underscore to do send it, and it has been it's inside a stack. Let's say it's a stack. It's pushed inside a stack. Then you're changing your current to do. You're not changing the one guy who you sent us. Obviously, string is a simple example where you can break it, but we are not going to work with strings anyway. We're going to work with objects and arrays, and they are always passed their arrays, right? Now, again,
What is the real concept? I mean, you are storing the previous bits.
yeah, you can go back. No, if you want, via this method, you can track what changed, and you can go back.
Okay, so what is the objective? What is the objective or you can have two types of things. Basically, it's different. So you are not really. So is it the
So let's say like this. Yeah, I will tell you it.
or just legal?
Yeah, obviously it will have different behavior. But let's say like this. We're chatting away. Then the client asks you for the offline session. You can keep chatting while the connection was severed for a few seconds. And the user won't know that the connection was off for a few seconds. And the chat, all the chats that you send will be there. But after some time, you came to know that these messages weren't delivered. You can see that in Hangout. And after some time, you get a message that this set of messages was not delivered. So let's try to implement that Flux. You're typing. Every time you're typing an engine, you're changing the store, right? And all of the changes or all of the action that was fired from the point where the connection was lost, you're constantly modifying the state, right? And if you come back, once the connection is established again, and since a lot of time has been passed, you can't send that data again. How will you go back to the previous state? How can you undo it? The application can't undo itself because the original guy who was there is no longer. He has been modified. But if I actually try to save it just after here, before I replace the underscore to do, if I save that somewhere, if I push that into a stack, and at some later period, I can fire an action that says undo and a timestamp. And then I can go into the stack and I can see at that timestamp what was the value of underscore to do, and then fetch it. Because every time when the state changes, you're actually replacing it. You're not modifying the same guy. It's not the same guy all the time. It's just something. If you are a fan of .NET transporter,
See, this to-do is a very harmless way. It doesn't have backtracing or cleansing or doing anything. So how does to-do get an additional functionality of backtracing? So just
no. The point is that you did something, an action was fired, the action was received by the store of the data updation actually caused the view updation. But then now you want to do an undo. Now when you do an undo, you can't tell him that please undo to this value. There is no point of saying like that, right? Because the guy who clicked undo doesn't know what was the previous value, right? And if an action is fired, store can't tell you what was the previous value because he changed the same guy. He didn't save it anywhere. Okay. Now, again, he changed to-do store. Why should the to-do store itself have a method called getState? It can be a separate guy and still to-do store here. Because to-do store only needs to do this any change to notify view that the store was changed. And along with that, expose another method, another just a simple function which is not part of the store to get the data. That's it. That's a simple simplification that was done. Now again, why do we need this to restore? Because I'm exporting this handle function and get state. So handle function, you have to call handle function to change the state, and you have to call get state to get the current state. So you want to use this store, but an action came through, so you just call handle and give that give action to that handle. You will change the state. Then you call get state, and you will get the next state. Right? You don't have to actually rely on unit anything and so on. So remove the unit emitter. How is that possible? The caller of handle function. Okay, in the last step, what we just did is that we are stripping away the powers of store. We are stripping away, making the store simpler. Right? We just want store to be a guy who exposes two things. One, a method to change the state, a method to get the current state. That's it. That's the idea of simplification factor. Now, again, the emit event was to notify the view that the state has changed, right? Okay, so what if he calls get state first, then handle second, and then get state again? So you have two results. First from the initial get state, and second from the second get state. You can compare them to decide was there a change? Is there a change? If there is a change, tell the view. If there is no change, I don't need to tell the view. Right? But previously, it will always tell the view that I changed. Does that make sense? Okay. Now, why do I need a get state? The handle itself can return the value, right? You don't need that also. Return underscore tools. Again, underscore tools cannot be directly modified. It's not exposed directly. It's a private variable. Now, again, the next question comes in: why should we have a local tools? Why can't I just send here? Right? Because first time when you initialize your application, you call get state. You have the current state. You have rendered the current state to the user, right? You have the current state, and then you receive that action, which means you have a current state and you have an action. Why can't I just send that to store and he will process and give me back the value? I don't need multiple functions. I can just do everything with the same function, right? See, there is a significant difference here. It was called handle, now it's use. And initial value is state. Initially, the state will be undefined, right? Because we just initialize. There is no true. True is empty. In that case, nothing. The next time when it came along, the action is add to, and there is a text, and you're actually pushing inside the function. Here, you have to see that this is the input. I didn't modify the input. I simply created a new array and I returned that array. So, sorry, that is the and I returned that array. So you have a state 1, an action. Then you call to-do with that state 1 and the action. And this to-do will return you back to state 2. Huh? No. Forget about the size because we are slowly moving away from Flux. The problem that Flux has, we are trying to solve it. I'll tell you. Don't get worried. So here, the most important thing that you have to look for is state action state. Why should you want to? Why do you want to destroy the state? First of all, this guy no longer actually keeps the state, does it? Here there is no local variable. This is just a function, pure function, who is given the current state and action, and he will return the state. So basically, you're no longer keeping the state anywhere. That state is being replaced all the time. You can keep track of that if you want to do undo. But you're not constantly changing the same state. You're changing this, modifying the state. You're replacing the state all the time. Yeah, I can keep it. Okay, that makes it much easier to actually do memory management because the old reference, there is no reference to the old state. Okay. The thing that we want to focus here is action take action. This is very much similar to accumulate a value to it, which is something like map reduce the array, things like that. Reduce, accumulate value to it. So whatever change from that case, it's like array of numbers. If you reduce it, it's like add. So initially index of 0 plus the next index, then you have to do I is equal to 0 and an array. So if it's 0, just value is equal to 0, I is equal to 0. So sorry. Accumulate initially is 0. Value, I don't know what value is. And the reducer will be like take the 0 index, add it with something which is right now undefined, and set it value. Okay, I'm messing myself. Sorry. Accumulate initially is 0, value is index of 0, and here you do 0 plus index of 0. So you have accumulated just the first one. The next stage, the previous value, which is basically array of 0. Plus the index of 1, array of index of 1. So if you have 2, 3, 5, 6, reduce will be the sum of all those numbers. Does that make sense? No? That was a very good example. Anyway, so now it's no longer a state, it is a reducer. It takes the current state and action to generate the next state. And that is a syntax where it says that if state wasn't defined, if it is a falsy value, it should be. You can obviously send to-dos empty array comma action or to-dos undefined comma action. In case it was undefined, it should be set to default empty array. And here you can see that empty array is the state and text is actually part of the action. The action is still there. We're going to actually go with, we're not going to use dispatch anymore because we're not registering anymore. So basically, reducer plus flux is Redux. Solve the same problem as flux plus some more. So let's try to understand data flow of how Redux works. This is going to be interesting. We have so many threads. And there is no dispatcher. Okay. Let's start with reducer. Because actually we should start with shape, but anyway, let's right now focus on reducer. You can have more than one reducer in the application, right? You can have more, like, you can have, since you have multiple states, you can, in Flux, there are multiple stores, but in Redux, there is only one store, and each entry of the store represents a state. Okay, let's just say, later on we are going to see an example of this. There is one state that represents to-dos and array. There is another state that has show all, show completed, show to-do. Completed and to-do, completed and all. So when you click it, you will see a subset of the to-do array. That's it like that. To-dos array is an array of all the to-dos that we have entered. Each of the to-dos that you have entered may have already been checked or unchecked, right? So to-dos is a state that represents all the to-dos that we have, and right. And then there is a visibility state that says that it is either show all, show completed, or show to do, right? That is the state of the application, right? It says that right now I'm viewing all to-dos, or it's right now I'm only viewing all the completed to-dos, or right now I'm only viewing the to-dos I need to work on, right? So that is the state. The second state is the to-dos itself. So store itself actually is a single state tree with two guys, to-dos and the current visibility state. What is the visibility? So we will have more than one reducer for adding to-do, with modifying the to-do, and another reducer for changing the visibility from all completed or all to to-dos or to-dos. So root reducer actually combines all the reducers, and he knows that when an action comes, which reducer should be called and so on. That's it. So here there is no setup file. There is no setup happening. It's just like this all in all. We have the same guy here. Container presentation similar to Flux. This guy doesn't actually print anything, and this is the guy who's going to be aware of what's happening in your Redux application. And this is just the guy who will be just give me some data and I will print it. That's it. So user just type hello. He has no idea what to do. He's going to go with the action linker. An action creator again will create an action, very formatted, pretty way of how an action should be. Then what happens? This guy is a dumb. Some person he doesn't know. He is not connected to these things. The only guy who is actually connected with the view is the rest of the application is a container view, and he will send action to your store. Now, store is a single entity. There are no multiple stores. One single store that has all the things. Okay. Now you can say that, okay, I just want reducer. So you are saying that every action flow can change states, the tree itself, because that will have some memory. That will be very, very expensive, but not like that. State tree is a big tree. State is a big tree with, store is a big tree of states. So whenever an action comes, only a subset of the tree, branch of the tree will be updated. Not the entire store. Sorry? No, it's a pure object. It's just an object, but only a set, only a part of the object will be updated. We will see how that happens. So, store just receives the action, and store doesn't know how to modify it. Right? I'm talking about he doesn't know how to modify the to-do, and he doesn't know how to modify the visibility. Okay. So he's going to pass the state, current state, and the action. Reducer accepts two things: state and action. Now that goes into the reducer. Now reducer knows that how it should be modified, how it should be managed. So this is the complete state tree. A part of the state tree is given to that tree. The guy who is actually responsible for modifying that subset of the state of the store. Okay. And he also gets the action, obviously, and he can actually based on the action he will create a new state. And he'll pass back to producer, which will go back to the store. So basically, store was an object, key value, key value, key value. So we got an action, he sent that to reducer, root, and reducer decided to only this particular key value needs to be updated, and particular reducer was chosen. He was given the action, and we built that subset of the tree. He processed that and it came back to the reducer. Reducer just replaced that key value in the state, and that store is that state is actually returned back to the store. Now once store is completed, there is a guy called root company. Again, is a React company who is notified that we have a new data. We have a new data here, and This is just a communication saying that the state has changed or the store has changed. Once that happens, we will request for the new. No, that is a pattern that it follows. It follows that pattern. We didn't change the original one. We didn't modify the original one. We replaced the original with a new one. Store master is written like state is equal to reducer state from action. So reducer is going to return me a value and I'm going to replace my internal state value. That's not correct, so that's the reducer. Immutability बताएगा बच्चा. Our state में reducer is not modified directly. No, reducer never actually changes it.
Changes basically mutability mutability is so we are arranging under the directly data store or data store mutability. The mutable aspect of something higher level instruction point to measure existing. So you can think of just something happening doing things so it's not they were array is going on like the third character module. That's mutability. Just replacing that.
Original cat can modify it's not good. Now, I know the source of confusion everyone I ran the previous example we saw that there is only one state and every time the state goes to the reducer, the state is a new value. Every time is a new value. Okay. But in a real life application, I can't have just one state, right? I will have multiple states. And all the states actually are inside the store tree. Basically, no more object, key value, key value, key value, key value. That's it. So every time an action comes in, the store will send that to reducer, and the reducer knows that for this action only this part of the tree needs to be modified. Not modified, but repeated. And that is what happens. So once your component knows about it, the information, the new state is passed down, and there are a few things that are missing. I'm missing on our Python. So I'll just try to show you the code, and I hope that you guys understand that. But anyway, I'll try to have a next session where we go deeper and do the actual coding. Python is not going to be the coding; it's going to be code that you can distribute and report to them. This looks very simple, and let me add. Every time I press enter, there was an action file type add to do with the text that was received by store. Hello, store. Redux. That was received by the store. Store doesn't know how to modify the state. So he sent that to reducer with the current state and the action. Reducer changed that state. Initial state was empty array, second state was A, third state was 2. Yeah, you have to understand that I didn't append to the same array. Yeah.
Website like that and the even also.
This one. Yeah.
Vijay Dev on 50 started the reference to state state
Right. There was only one store, but an application can have more than one store. State. I'm going to create a tree of states.
So the entire state can matter.
Alright. When the state gets an action, when the state gets an action, he or goes out of please replace I don't know where to. That goes to the root reducer. He knows which part of the state should be changed. I will show you the code. I know there is lots of information to be filled, which cannot be done in like less than 1 hour. But I will try to. Okay. Okay. So this guy here. Okay. So this fragment is the to-dos array, right? Not the visible key, which is this guy. There is no completed one, right? So it is active. But it's true because we are in active mode. It will only display the actives. I told you. Okay, so there are two states. In state 3 will have two entities. One is produce, and the second one is what is the current visibility value. So we need two reducers. The first guy is going to modify the current to-do state to the next state. Okay, and the second reducer is the guy who is going to take the current visibility value, which is all to active. Okay, so let's say this action is actually add to do. That's going to show that reducer element. So here right now, this is just the part of the state called to do's. Okay, and this particular reducer is going to add a new to do to the X. So not to a whole new array, and that array is returned here, right? And that new array is replaced by the root reducer in the state tree. It's okay. Okay, so let's. So first of all, you said that action types are to-dos and so on. അതെന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഈ കോഡ്സിനകത്ത് കുറെ ക്യാപിറ്റൽ ലെറ്റേഴ്സ് ആയിട്ടില്ല. So capital letters actually, capital variable names are actually constant, right? So why it has been created is because everyone can use the same value. if you are saying as a string in every place, chances are that you can change that string anyway. Different file have same string and many people are working together in the same project. One guy can change the string to something else. So we are going to create constants. Simple add to means add to do and so on. So rather than using this in your application, you will be using this. That's it. Okay. And these are the action types: add to do, toggle to do, and set visibility. And then what a filter on should it show all, active, or complete. Make sense? Now let's directly jump to reducers. So I have first reducer called to do, just one to do. He got the state and he got the action. State is just one to do, not the array, just the one to do. Okay. And he check the type. If it is add to do, this is what he needs to return. Just bear with me, it may not be meaningful what's happening here. If it is a toggle to do, uh, again, you have to do that and returning a new object, not the actual object. The actual object will have a completed, and replacing that completed with the flip flag. I have no idea why I do this right now, because I'm blank.
Maybe changing, looking on the same state.
Yeah, it should probably work.
No, you are in a state and you are keeping the.
No, I know why I wrote it right now, but I will tell you in a second. But anyway, if there is, if it is an action that doesn't concern with add to do or toggle to do, or he just failed to send the action itself, I'm just going to return the state itself because I am not changing it, right? I didn't say it. That is just a reducer written to modify an entry of the array, not the array, an entry of the array. Actually, the reducer composition JS number, actually everything was inside this single reduce Adinathan and just separate this. Now this is file that we just do.
In your previous code, you were comparing state ID.
Yeah, I will tell you. I'll tell you how it works. So here, this to-dos is a reducer to change the to-dos array into a next array, replacing it, basically. So if it is an add to-do, create a new array, have the original array there, and the new guy. The new guy. So which means that it's a new guy, which means it didn't have a previous state, right? Okay, so I actually imported to do from to do. Okay, and here I have add to do. So basically, what I need to do here is just this. Oh, come on. Okay. It will still work. Right. So I actually moved that up. So here, since I'm going to add a new one, which means initial, there is no initial. That's why I send the initial state as undefined, right? So this guy is just going to return that. That's what's happening here because you're adding a new to do. Okay. Now the next one is toggle to do. State.map. Array map you will return, you will get a new array. Array.map never modify the original array. Okay, that's again a new thing. Forget this one, this is an arrow function. Basically, it means that's it. The only problem with this function is if I do this will point to window, not this function or this function. Do it function order. See this guy, same function. Arrow function. If you're using arrow function, this will be preserved. Oops, again, this guy will what to be. Okay. Now, toggle to do one, which means you're toggling one to do, right? But you have to process it over all the to dos. All of them. So, which means you should not process a to do which is not the current one. Right? You're only toggling this guy. Come on. My home transaction. So when I click that, an action is fired called toggle to do, and it will have not the text but the ID of the to do, right? So I'm passing the action here. The action has an ID, and also the state has an ID. Again, this is being iterative. Okay, let's actually try to replace this code here, which means this doesn't make much sense to you. Okay, so I don't need this. So, not this state. Right. Because inside map, each function, this T represents I of that array, right? So if I of that array, if it is not the guy who actually I clicked, because the action represents the to do that I just clicked, right? So if it is not the guy, I just don't make any changes. And if it is, okay. See, I don't have hot loading, that's why I reloaded it. Because if I had hot loading, I don't need to reload, I can just simply click. I know. There is no difference. You want to spend time on this? Okay, good. You got the idea of how this reducer works, right? I don't know why it's left. It's more. Or you want more? Okay, so that is just the reducer to do and to do's that will get the state and try to that will return back the next state. Again, I have used reducer composition because this guy can be used by not only this to do's but also some other guy. Okay, it's just one to do's. You can have like I can't remember any. Anyway, so that is a reducer. You have also the visibility reducer. So it's very simple. By default, if you don't pass anything, if you don't pass state, assume that it's show all because show all is the default. Right? And the action, and you try to find the type of the action is set visibility. Basically, this is your current state. It says that it is show all. Now you set a new action that says it should be something else. So just replace that. The only problem with this code, right? This code is very simple. These are the only three values that is possible. The reducer is simple. Replace the old value with the new value because it's a string, right? It's not an array of objects. Or it's not an array, or it's not an object. You are replacing the strings, right? From all show to show active to show completed. So here you can see that it's just returning that, which means it will be replaced, right? No? Yeah.
Maybe that there's a 10,000 to lose.
Yeah.
And just toggle just one to lose.
Yeah. It will go to the map.
That's very bad.
That's one part we are leveraging on the browser vendors that they will do the appropriate improvements in the browser so that the array.map is much faster as compared to the older browser. Which browser tool? Sorry?
I have 10 items in the map. Will run.
No, it is iterating, right? Sorry? No, it's like when you use when you say every time the function is coming, as soon as you do that, there is an empty created. Every time this function is called, this is modified and added here. So how it should be modified is part of the function. So let's say v.map is equal to map function. Function will get the item. Item. Okay. And what I want to do with this return item into item. So basically erase it to right. So the first time it happens, this is your array. Second time it happens, this is your array. And so on. So B is not changed. You created a new array and the array is basically push is happening.
With the map function, you work with
No. That's a good question actually. Browser can do that on his level, he can do that. Huh? What his question was, since he is going to do that individually, why can't we just fire all these things at the same time? Rather than do that, then do this, then do that, so on. Why can't we just fire all of them together? Why can't we fire this function 4 times at the same time. Yeah. But again, that is not possible in JavaScript execution because JavaScript itself is single threaded. So you won't have 4 functions running at the same time. Still, it's again single threaded. Okay, do you want to continue? Okay, so what I can do is tell you that it is good. Why? Because the popularity of React, Flux and Redux is going very, very high. If you don't know, you can Google about it. You end up with an application that has a predictable state. You end up with an application where each layer of your application, these guys, they do one single task and they do it well. Yeah, single responses. There is no many, there is no many connection. You have a reducer whose purpose is to just create the next state. You have a state that holds the data. You have a container view who understand what is being changed. You have a view who doesn't care about anything. He doesn't know anything what's happening. He just gets data and he presents it. Now, on top of that, since the state itself and the logic to change the state are two different things, you get a lot of debugging to it. You can keep track of what changed, who changed it, how it got changed. Everything that is happening in your application is an action basically. So you can actually commit those actions if you want to. Every action can be pushed into the stack. Every state modification itself can be pushed into a stack, and you can track pretty much everything. At the end of the line, you know that what's happening in your application every single time. So the next time you're going into Facebook, you're not. Let's try to do that. Log into your Facebook, open a couple of other tabs, and be on that tab. And you can ask your friend to ping you, or before opening those tabs, you can go and post some snippets. Post in Facebook so that people can comment on it, react on it, put some likes on it, which means basically you will get some notification in that particular browser window, right? And keep it phone beside you, make sure it's connected. So the moment you post, the post is out there, the application is running on the tab, the application is running on the phone, there is a backend page with server. So the moment someone else likes it, he's going to send the network activity is going to happen both on your phone, push notification, and also in your browser, because the browser is actually either polling or he has a WebSocket running at the moment. The browser will know, the application will know. The moment the browser came to know about it, let's put aside the app for a minute. The moment the Facebook application knows about it, from the WebSocket push, we will create an action. The action is increment notification. Do I need to send some data with it? No, because this is just a pure action that says that please increment the notification count. That's it. This happens when he received a notification. He received the data from his WebSocket via the WebSocket from the Facebook server. As soon as this action is fired, it will reach the store. The store will call a reducer. The reducer will increment the value, right? It's going to increment the value. And you have to understand that I didn't change the original variable count. I replaced the count from 0 to 1. That's the purpose of the reducer. He's not going to increment the count. Okay, he's going to return the next value.
So memory will send it to the server.
I'm coming to that. So WebSocket, action, store So to reduce the track to store, the count value is now 1. Now once store is updated, the view will change, and even though the tab is not open, but in your Facebook, it now has a red icon with 1 in it. But at the same time, you also saw it on the phone. And once you saw it on the phone, the application, the Facebook app is going to send another WebSocket request or normal request to the Facebook server. And the Facebook server, since he has WebSocket connection to your browser also, is going to send that back. Now in the application, there is a guy who is going to create call for the action created. And that guy understands that the notification has been read. So which means that in the initial draft, we forgot one thing, which is every notification, I can't just simply update, make it up. I can't just increment the value and decrement the value. I need to have a tracking ID for each notification. So when the notification came, the action is being fired not only has the type called increment, it also has the ID, tracking ID. Okay, so now you end up with two actions, increment and decrement. But it doesn't make much sense if you have a tracking ID. You can just create one single action called change notification and tracking ID. Right? And in your store, you can track which notification you are talking about. Okay, and if it's a new one, increment it. If it is a okay, this is actually a reducer part. The reducer is the guy who is going to decide if he wants to increment it or decrement it. Okay, so with the whole pipeline, what happens here is that inside your program, notification came and the notification left. And the user, when he comes back to Facebook, he won't see that ghost notification count. When he clicks that, it's the same one that he just saw on your mobile phone. Okay. So now your Facebook application is a predictable, has a predictable state. Something similar happens with Gmail also. Even though I'm not sure if they use it or not. If you have views that made in your phone, in Gmail it will be marked as well. It won't stay unread. So obviously, even I can't say that they're using something like Flux. They may have something like Flux to make sure that their state is always predicted. The same concept applies to the Gmail chat. You can reply from your Hangout app from your phone, and when you go back to your Gmail, it should not say that you have 3D chat. Actually, it does. So we can say that there is no Flux like anyway. Interesting, but lots to study, right? Lots to understand. It's like this. Initially, when I started with the presentation, I told you that this is not what you have been doing up until now. Something like data entry is not what. It's a very new frontier. You have to think it slightly differently. The objective why you are thinking it slightly different is to have your application a predictable state all the time. Okay. I wish you all this. Okay, by the way, you can reach out to me. You can just Google Vineeth.com and go there and get some links. Or there is another thing called GDG that happens every year. Google discussion group, random. I would video.
When is it happening? DBG, when is it?
The event happens actually the next one will be most probably once Google I/O. Okay.
Okay, thank you. I take this opportunity to thank Mr. Vijay for actually sparing your time and rendering such a wonderful session. I also thank all the participants, actually the audience, for taking the pain of coming to our office and being a part of Coffee at DBG. I really appreciate the effort that you have taken. Now, as a token of our appreciation, I invite Mr. Shamir Mr. Shiraz, to present a memento to Mr. Vijay.
Okay, I have one last point of view. The last session, I think most feedback was we should have, we would like to have a live coding session. So I did that here, but what I understand from guys, from experience as speakers to many other places, is that they enjoy watching that. It's like watching movies or series. You watch that, you got the idea, you enjoy it with your time, and once it's over, you just go back to your life. You don't do much about it. You just watch that video and then either you will watch it to the entirety and have satisfied, or you watch something in the point where you understand and then you just quit it. Right? It's okay to quit, but it's not okay to just understand and leave it at that. If you're really interested in doing something, that's why I believe you guys are all here. Others have to leave. It may not be because of same reason. But the point here, what I'm trying to make here is that all the things that I just presented, it didn't came to me in one day. I had to understand, I had to do lots and lots of research to understand that. Even now, it's still continuing in so many places how things will work. So the only way to understand and learn and move forward is to not only just watch, but try to see and talk. Thank you.
Well, that was a striking point.